First question of exercise 3 in relations and functions. So given function 1, 3, 4 mapped to 1 to 5 and function g, it is mapped from 1 to 5 to 1, 3. Now we have f, the subset, we have subsets of f 1, 2, 3, 5 and 4, 1. Note that this we have got from mapping 1, 3, 4 to 1, 2, 5. And similarly by mapping 1, 2, 5 to 1, 3, we get 1, 3, 2, 3 and 5, 1. What we need to find is GOF. Need to have this bracket here actually. GOF is nothing but g of f of x. G of f of x. So GOF of 1 refers to g of f of 1. And what is f of 1? This is 1 f, and f of 1 is this. So f of 1 refers to 2, and hence we have written for f of 1 here we have written 2. And now g of 2. So look at the given subsets. In g of 2, this is 2 and this is your g of 2, and hence we get 3. And one of the subsets in GOF is 1, 3. Similarly, GOF 3, g of f of 3. For 3, we have f of 3 equal to 5, and hence it is g of 5. For 5 here we have g of 5 equal to 1. So this is another subset. So g of f of 4 is nothing but g of f of 4 here, and again f of 4, this is 4 and this is f of 4, which is equal to 1, and hence we get g of 1 which is equal to 3. So just rewriting it, we get 1, 3, 3, 1 and 4, 3, which is GOF. Question number 2. Let f and g be two functions from R to R. We need to show that f plus g of h is equal to f of h plus g of h. First we will solve this. So f plus g of h equal to f of h plus g of h. First start with LHS. So f plus g of h is nothing but f plus g of h the whole x. So this variable could be anything. It could be y, it could be m, it could be k also. However, for simplicity sake, we always take x. So f plus g of h x is nothing but f plus g of h of x. So we are just writing this as a separate function. So f plus g of h of x. Now again we get f of h of x and g of h of x. You can separate these two functions, and this can be written like this. So this is f of h of x. So foh of x we can write, and goh of x we can write for g of h of x. Now eliminating x, we get f of h plus g of h, which is equal to your RHS. So what this proves is, when the sum of two functions or combination of two functions is mapped to a third function, it is equivalent to these two functions mapping to h separately, like f of h and g of h. Now second, f dot g of h equal to f of h dot g of h. That is, the product of two functions mapped to a single function is equal to the individual functions mapping to the third function separately and its product. Consider LHS. So f of g of h can be rewritten as f of g of h x. So we can again write f dot g of h x as f dot g h of x, or multiplying inside we get f of h of x dot g of h of x. So which is again f of h dot g of h.